I think we'll get it going, fellas. If I may have your attention now, please. The speakers in this part of the afternoon session are Doctors Lucky and Kleinrock of AT&T Bell Laboratories and UCLA, respectively. And as with the earlier session, we shall allow you to read their biodata, and I therefore now will call on Dr. Lucky to start us off. Dr. Lucky.
Thank you. I had this curious sensation that with all this equipment around, I'm not really giving this talk in real time. You know, when we come back in 100 years from now and they have a program just like this to celebrate the next century, the room is going to be the same. Maybe there'll be some pictures of some of you people up in these empty slots up here. And the people in the chairs are not going to be very much different than you are. And the only thing that's going to change are these things. You know? Because the technology is going to whir by us, and this communication, I think when you come back from 100 years from now, meetings will run differently because of that. But meanwhile, I'm stuck with this 100 years, and it's slightly intrusive. But let me get right down with it, because 30 minutes is not a long time to talk about an interesting future in communications and information. If I go back 100 years, and I'd like the first slide, please. If I go back 100 years, maybe if I push the button. Could I have the first slide, please? No, that's the second slide. Can I have the first slide? No, I go backwards. Okay. 100 years ago, we had an all-digital network that spanned the United States. It was owned by the largest corporation in the world, Western Union. Now, it's ironic that after 100 years, we're striving now to get an all-digital network that spans the country, and by the year 2000, we will not have yet accomplished this goal. But of course, the goal for many in telecommunications is ISDN, the Integrated Services Digital Network. But Alexander Graham Bell invented analog. And analog took over, and through clean living and hard work, Alexander Graham Bell's company became the largest corporation in the country and in the world. And for this, he was rewarded. His company was pulled apart. Now, I'm not here to decry the death of the Bell system. Nobody in my company does that anymore. That's water over the dam. And what you get is your own problem. But it does remind us that the future in communications is not only belongs to technology, but it's a socio-political field also. And the events that take place in sociology and politics are going to make just as much difference as the technology. There's many things we can do with technology, but the economics, the acceptance of the people are going to determine what comes in and what doesn't come in, as we've seen many times in the past. Now, like Bob Frosch, I want to make a caveat that you can't really predict the future. And furthermore, I want to go further and say that technologists are especially bad at this. The problem here is that we're too aware of the problems. And we're aware more than other people of why you can't do things. It's part of our tradition. And therefore, we are really pretty bad when we look at the future, because we see the problems and just don't let our imaginations roam free as to what might be done. Furthermore, this is a particularly significant year to look at the future, because when I was a youth, one of the things that really impressed me was the book 1984. And, you know, like many of you, I thought we'd never get there. And here we are there now. And in the book, of course, the invention of the telescreen was what really determined the enslavement of the people. And in fact, we've seen that just the opposite has happened. Well, actually, we don't have telescreens yet. We don't really have two-way video. It's been one of the real failures, in spite of the fact that the technology is sort of there. But the technology can also affect politics, and it hasn't worked out like this, at least in the free world. I want to look at the trends in technology in transmission first, and then switching, and then networks, and then look at what it means to people in their everyday life in what remains of the time I have. First, transmission. You know, back 100 years ago, the only kind of transmission we had was wires, and such great breakthroughs that came from the early AT&T as the 40-arm pole, which is a space division multiplex, a way to get more and more conversations across the country. We're still trying to perfect that. But you know, it was only 1961 that the first microwave system went out. And now, of course, those are taken as a matter of course, and they take the lion's share of all the long-haul traffic across the country is carried by these microwave towers, and yet they only came about in the 60s. So that's fairly recent history. The 70s then were the decade for satellites, and satellites opened up worldwide communication. Today, of course, they're important, but it's ironic again that they are in the plans for the long-haul network in our country. Probably satellites will be phased out. That's not to say that satellites won't be highly useful in communication, because they have many, many roles. But probably not in point-to-point communication in the long-haul telecommunications network. I have a picture of a recent shuttle launch, in case you don't know how they do these things. We're working on cheaper ways to do this. But the 1980s and the foreseeable future, as far as I can see it, is going to be owned by optical transmission. These hair-thin fibers can carry enormous quantities of information. And I want to convey to you a couple of things. One is that today this is a primitive technology. I have never seen any technology change as rapidly as optical communication is. When you come back 10 years from now, you'll think what we're doing today is just we didn't know anything about it at this time. We're doubling the rate at which we can transmit over optical fibers every year. And people who work in this field will give you arguments why we can't go much further than we'll be able to go in a couple of years from now. But I think history has shown that whenever you have an exponential trend in technology, it tends to keep going, regardless of all the reasons why you can't do it. And if you look at the theoretical potential of fibers, it's 5 orders of magnitude away from where we are now. 5 orders of magnitude. And I think that will be a tremendous forcing factor to determine the future of technology, because of the enormous potential that fibers have as an unrealized form. The information is carried by on-off pulses, transmitted by lasers that are teeny little things. This is one laser shown on a cube of salt, in case just to calibrate our thinking. Everything these days is small, everything is fast. And these are getting faster, if not smaller. The Bell system, not the Bell system, AT&T Communications is, sorry about that, is busy putting these across the country, as well as the other common carriers. All have plans, and this is an old view graph, so that it's somewhat different now. But I do want to give you the idea that in this decade, we are spanning our country and the oceans with optical communication links, which within a year or two basically are going to be obsolete because of this exponential change in the capacity of fibers. The metropolitan areas are already crisscrossed with fibers, and the point where they're not is they're not out to the end customers. They're going out in the local loop as far as a serving point out toward the residential customers, and in the case of some businesses now, they're going into the basements of buildings. But the work of the rest of the decade, the rest of this century really, will be to see these fibers come out to the homes and to the offices and bring this enormous capacity out to the end user. Now, of course, I'm aware that two-thirds of the cost of communications is in the end access. And when I look at what fibers might do, they might make the long-haul part free, relatively speaking, and leave the bottleneck, as it always was, in the local access. And I don't expect to see that change. But what I would like to see happen is, as all this bandwidth is made available, I would like to see voice channels transform to video channels, to use all of this bandwidth that we have available. I think this, so that the cost of a call probably will not change that much. But instead of getting a voice channel for your money, you'll get a video channel, a wideband channel, and that will be how this excess capacity is used. I think it'll be a tremendous forcing function toward video. There's also the possibility that there'll be a glut of capacity available, with everybody putting in these optics and with the capacity doubling every year. Every time in the past when people have predicted gluts in capacity for information, it hasn't happened. And I have a feeling that we'll find a way to use this capacity, but I could be wrong, and there could be a time, not in the near future, when we really overbuild in capacity, and it probably will hurt the relative economies of the long-haul carriers. When you look at the future, to give you just an idea of what's going on here, we have if you look at the attenuation, and to get a little technical here just for a minute, of a fiber as a function of the wavelength you transmit it, there's a well there where you have a bandwidth that you can transmit. I want to make one point, and that is that we haven't used any of that bandwidth yet. We're transmitting a single wavelength. In some cases, 2 or 3, but basically a single wavelength. It would be like AM radio with one channel on it, or television with one channel. And yet there's room for about 5,000 channels in the bandwidth that we have available currently, or optical channels. Each of these 5,000 channels could handle at least 2 gigabits of information. That would mean on a single fiber you would have on the order of 30 terabits of information, theoretical capacity. That's enough to give every single person in the United States a 64 kilobit per second channel, and multiplex them on a single fiber. So you're talking theoretically of huge capacities. Now, of course, my friends in the business would argue that they don't know how to get to realize that capacity because there's some key inventions missing. In the microwave and radio area, we can do mass amplifications of signals, and we can do mass regeneration of signals. We can't do that in the optical world yet. You have to be able to handle all these channels without having a proportional cost. You can't have the cost of n channels be n times the cost of one channel. We don't know how to do that yet. But I predict that we will learn how to do that, and we'll open up these enormous capacities. I want to make the point once again that if you look at the unrealized capacity, and that's basically what the 2 colors show on these bars, that we've used up all of our other media, and optical media has 5 orders of magnitude theoretical capacity that remains to be uncovered in the years to come. And I think that this will color and flavor and force the communications revolution in the years to come. There are other factors I want to mention before I leave transmission. One of them is cellular, mobile, and this is only one element of what we call bypass. I think everyone will want to bypass the local telephone companies, including the local telephone companies. And it's going to be an interesting world out there. There are many, many ways to do that. The cellular technology could become the basis for home phones and for office phones and for everything. We could change the world into, instead of a fixed location, into a logical location, and remove place as a constraint in placing calls. But there are other possibilities for bypass, atmospheric optical, microwave radio collection. There are many ways, and many businesses, of course, will go with high-speed digital links directly out into the long-haul network. And it'll be a very interesting, not only from a technological technological point, but from an economic point and a survival point for many, many companies who are trying to get a part of this business. CATV also, of course, will be in there, direct broadcast satellite in many ways, and a lot of other alternatives will exist, but it'll be an age of alternatives for transmission. To summarize in transmission the trends that we have right now, analog goes to digital, voice goes to data. For the future, voice could well go to video. Fixed will go to mobile. Electrons will go to photons. Narrowband will go to wideband. And the traditional access rate in the home will go from 1200 bits per second, say, to at least 64 kilobits per second in the immediate future. Let me now turn to switching. When you look at the old days, we did it manually, and there was a time not so long ago when we thought that we would require more telephone operators than there were people in the world. There was an exponential trend in the number of operators being required. Whenever you get that kind of trend, you know that eventually it saturates and the technology changes. And in switching today, we have a trend that looks just like that, and that the cost of development for each switch is an order of magnitude more than the previous generation, so that if you follow this trend, the next generation of switch would cost $1 billion to develop. And obviously something has to give, and so it's my feeling that the big switch will stop. And you realize that most of the cost is in the software, and that we'll have hierarchical assemblage of little switches. During most of this decade, during this century, we've had space division switching, and only recently have we moved to time division switching. And of course, the new switches are that way. But even more so, the trend in local area networks is to packet switching, and eventually I think that you'll have a world where you can plug anything in anywhere, hopefully, and voice will probably be largely carried by packet communication. Voice will be assembled into packets and switched. And you'll be able to dump any kind of information into the local switch in any form, be it video, voice, data, whatever it is, and expect the network to take care of it. Now again, we need inventions. And one of them is that if we indeed go to video, because of the capacity available in optical fibers, there'll be no way to switch this using current technology at all. And we have no way. You'll dump all these bits into the switch and there'll be no way to switch them, because the time division switches will never be able to keep up with the high speed of these streams. So what we need is an all-optical switch. And again, I predict that it'll be done. It'll be invented, maybe within the next decade. All-optical switching, so that, again, electrons to photons, and the world of switching will catch up with the world of transmission, and the form will be kept in optical, the signals will be kept in optical form as they go through the office. You'll have variable bandwidth, packet switches, and as I said before, they'll be modular, hierarchical, and build out of small pluggable things. The trends in switching: hardware goes to software. Simple goes to very complex. Centralized goes to distributed. Calls go to packets. Fixed bandwidth goes to variable bandwidth. A little bit about networks. Again, in the good old days, we maintained iron control over these networks. This is from Dr. Strangelove. Those are the good old days when everything was centralized and controlled by one good company. Now, we went through a period recently in networks. In fact, we're going through it right now. We're really building a Tower of Babel, where the computer world has given us all different kinds of terminals, all different kinds of protocols, all different kinds of local area networks, and all these things. And it's a world of logical complexity. And the technology is all there, but the logic isn't all in place, how to do this. And when I look at the last decade or so, some of the great breakthroughs were not in technology at all, but were made around tables in Geneva and places like that. I consider the X.25 packet protocol, it was one of the great contributions. And even more so, I think that the open systems architecture, the ISO 7 levels of layered architecture from the physical level up the hierarchies to the application level, a conceptual breakthrough, a great contribution, a way of looking and managing the complexity of these information networks. And those kinds of things are going to be the important breakthroughs in the immediate future, rather than the technology itself. We have to control the Tower of Babel that we're building in the way we make things plug together, in the complexity of software that we have, and in the complexity of our systems. The trends, centralized to distributed, call to packet, regulated to unregulated, and public to private. Some of the things that are happening in the networks now are they're becoming customer controlled. They're no longer central. If I look at the network of the future, I expect that it'll be a logical entity out there that you won't worry about very much. They'll be like the electrical plugs that we have on our wall right now. You'll be able to dump anything in the network and let the network worry about how to route it, how to take care of it, and even to help you with expert systems and the access and getting to distant computers, hosts, and getting around this complexity that we're building up right now. But it'll be customer controlled. You'll be able to, as a customer, to remotely control the network yourself. You're part of it, which will be a logical entity, not a physical part of the network, but a logical division of the network that you'll be able to control. It'll be software defined. Many customers will have direct high-speed access into the network, and they'll dump large gobs of stuff into it. There'll be intelligent gateways that sort out what goes in and how to handle it, how to route it, and will take care of your protocols. And as I said, expert system help in getting into that. Well, what does all that mean? I remember being at the last instant put on some talk show in Cleveland. And I wasn't expecting, as I ran up the stairs to go on television, someone said, "You've got to have a prop. You've got to have a prop." And so someone handed me a piece of optical fiber cable, and they said, "Take this on television and tell the people what it does for them." And I ran up the stairs holding this piece of fiber, and I couldn't think of anything it did for anybody. I'm still having that trouble. Because what difference does it make if you've got all this enormous capacity out there? It can make a lot of difference, and so far, maybe it hasn't, except to hold down cost, which is, of course, very, very, very important. But to the average home, what difference does all this make? Well, in the home of the future, I expect it'll be filled with gadgets. Because that's going to be the way things are. Computers will be littered everywhere. You know, when you sweep the floors, your vacuum cleaner bag will be filled with computers and stuff like that. When you open the door, computers will fall out the door. And they'll be embedded in all kinds of things in the home. But to me, the thing in the home that makes a difference is entertainment. I don't care it's the information age. I think that the home is ruled by entertainment, and the invention that has changed people more than anything else is television. And I expect to see that continue to dominate the home of the future. And I think that all the attempts to get information into the home will be semi-successful, but it'll have to be sugar-coated, and the way to the home will be through entertainment. Now, this is probably owned right now by CATV. It'll be difficult for the fibers to get into the home because CATV is already there. Fibers can offer switched video services so that you can say, "Look, I want to see Gone with the Wind right now." And there'll be some service that can offer it to you right now because it can be switched right into your home. We'll certainly invent a very good projection television, widescreen, high definition, high brightness, guaranteed to come in the next 10, 20 years, if not even sooner than that. And in fact, if you're looking at 100 years, I would challenge the people who make displays to let me sit down with Archie Bunker and his family in my living room. I don't think it's undoable. I bet Disney could sort of do it right now. But I think that the way in which we display entertainment in the home probably go through several revolutions. And there'll be a crisis probably in the amount of material which is available, because already there's more channels than I can handle. I think you'll have expert systems that'll help you get your entertainment for the night. You know, they'll discuss your needs with you. Anything you want to read into that? There is a place for the home computer. I think it's in the closet. But I really don't see a big role for it, because I think computers will be integrated into everything else. But computer terminals everywhere, of course, are going to become more and more friendly. Not as friendly as that dog, even a mean-looking dog like that. But they'll become very friendly. They'll have speech interfaces, natural language understanding, and the systems itself will be the ones that people find easy to deal with. And that'll be a very powerful motivating factor. And the reason why I, for one, don't believe in this gap between those that know how to use computers and those that don't. I think there's so much money in bringing computers to the unwashed masses that they're going to be brought there, and you won't have to know anything about them whatsoever to use them. So I don't see that kind of a crisis developing. There will be information brought into the home. Videotex is trying to get there now, and going very slowly. And because I think that that entertainment so dominates the home, but it will get there. It will get there. And I'm impressed by the possibilities of these bulletin boards, the electronic mail in the home, the CB radio phenomenon, where you can reach out to other people. Kids in some of the trials that we've run been able to draw pictures and hang them on electronic galleries, and a way of really getting together with other people rather than just accessing information, which I feel is not going to be terribly popular in the homes. Furthermore, there are possibilities for other kinds of entertainment, like playing bridge and other games with other people around the country remotely by telecommunications, or to really get into games through interactive terminals, so that you'd be able to drive cars, you know, against other racers around the country who also dial in for the Grand Prix race that night. Or we could recreate the Second World War, you know, entirely with telecommunications. However, it's interesting that these things can be done today, but they're so conceptually hard with the amount of software that would have to be done that they verge on impossible to do really meaningful things like, I think this is a hard thing, but not impossible. But of course, recreating the Second World War is really a dream that will never, fortunately, be accomplished. Now, if I look at the office, of course, we'll see that the telephone and the data terminal will be combined in some form. There'll be lots of gadgets there, too, and lots of different ways to do it. There'll be expert systems in the offices, and we'll bring the information age there. But I do note that some of the real failures in the information age thus far have been management information systems. I gave an assignment once to a group that I had that worked in office automation, and the president of our company wanted office automation, so I told him to get some office automation for him. And they came back a couple of weeks later to report complete failure, and I asked them what their problem was. And they stammered for a while and said, "We don't know what presidents do." And it's profound, I think. The problem is many jobs are ill-structured, and they'll be very, very hard to automate or help with expert systems, either management information systems or expert systems. This is supposed to be a good picture of the information age, but to me, it indicates what I don't think should happen or what I don't think will happen. I don't think man was made to sit behind CRT displays. And I think that these jobs are going to be automated and go over to machines, and I don't expect the information age of the future to be like this. As a matter of fact, I have personal problems with the information age. I already feel I have too much information. I get 10 times as much as I can read. See, while we're busy with technology making it easier to access and store information, you're going to have universal access and gobs of storage, and you'll be able to get any fact you want if you can pay the price anywhere you want it. But the problem to me is a problem of changing that information into knowledge. And it's an enormously difficult problem. It's like the problem, going back to the friendly terminal, it's a problem of language. That we have built a beautiful, depending how you look at it, barrier between us and machines, and that's our language. It contains such nuances and such depth of detail that even in the next 100 years, I don't see machines having fluent conversations with us or really understanding what it's all about. And given this, I think they'll find it very hard to help us with many of our problems in business. Even though information becomes a commodity of land, I'm going to need a lot of help dealing with it. You know, I'm just a mundane thing like if you want to look up some information on some technical subject, and you go to the library, and we've got these beautiful computer systems that will give you 300 references on the subject, and they won't tell you whether any of them are any good. And you know that 295 of them are totally useless, and they're going to make you look at them all. To determine this, we have to find a way to value information and to give you much more help than just to dump it all on you. That's what happens to us right now. I get, as I said, 10 times as much as I can read every day. And hopefully you can get a machine to read it for me and let me know what I have to know. But unfortunately, I think those are extraordinarily difficult problems even for the next 10 years. Maybe the office of the future will look like this one at MIT, where you sit in front of a backlit wall that has an electronic filing system out there, and you can turn pages. It's the analog of the piles that we have on our desk right now. You can look under a pile because you remember that you just stored something 3/4 of the way down on this pile up here on the right. I always do that, and the minute I file something and put it under a particular subject, I can never find it again. But I remember where it is in piles, and people like Nick Negroponte at MIT, and this is his lab, have done some very interesting conceptual work on translating electronics to things that we understand from the way that we run our offices right now. But again, I think these are extraordinarily difficult problems. I would expect to see offices equipped with picture phone meeting service, or video conferencing services, I really should say, using a generic term. This, again, to me, has been a failure of technology in recent years. The whole idea of displacing travel with communications is still a goal out there that we probably won't really appreciably dent before the year 2000. Because, again, of the nuances of human communication that we really don't understand. The technology is all there, and with this capacity that's coming along from fibers, and plus the fact that the bits needed to transmit pictures is also going down exponentially. And I expect to see a day not too long from now when you'll be able to transmit video conferencing material over voice bands at 64 kilobits per second. And it'll open up a whole world here of video conferencing. But unfortunately, I think it's much more determined by the sociology of meetings, which we really don't understand very well, and the pace of understanding that is so slow compared to technology that I despair of making dents in that problem. I do believe that personal picture phone will come back. I owned one of the last picture phones in the world in the last decade. There wasn't anyone left to call. The bandwidth will be there, and I think the sociology will not. But I don't think the sociologists are going to find out for us. I think that we'll find by economic trial and error, and somebody will make a business at this, but it'll be kind of hard. In fact, as I look at the future, let me just end with a couple observations. You know, you hold out ideals and say, this is what we're aiming at. This is what we'd like to do with communications. And when I think about it, suppose that independent of technology, someone said, look, I can give you magic. I can give you any kind of technology you want. What do you want for the ideal communication? And I think that I'd like to have a wristwatch that would have a video display on it, and I could call anybody in the world and get their picture and get live audio and video on my wristwatch right now. And, you know, I think we can do that in the next 100 years, but I'm not sure I want to. Because I'm not sure I want other people to get me that way. You know, if you call somebody and they don't answer their wristwatch thing, are they dead? Or, you know, it's always trade-offs between availability and privacy, and we're going to fight many battles like that. So I'm not sure I want that ideal in communication. I want to maintain some distance from availability, and yet I want access to everybody in the world. I want to be the only one with that wristwatch video. I could go on in that array, but let me give you one other idea. There are many other senses, well, obviously, than speech that we've gotten along with the last 100 years, and opening up the video. And through robotics, we have the possibility of extending our manipulative power through communications. And who's to say that we can't do smell and touch and other things? So that, for example, here is Half Moon Bay in Tahiti. And suppose I wanted to go there and I could rent a robot and go there via something we call telepresence, which might be another ideal for communications to emulate. I, here in Philadelphia, wear a suit which is connected by telecommunications lead to a rent-a-robot in Tahiti. And as I move my arm, that information is transmitted and the robot moves its arm in Tahiti. I see through the eyes of the robot, I hear through its ears, I feel through its sensors, and so that every one of my senses is remoted to Tahiti. And so that I can walk down the beach, and as far as my body knows, as far as my mind knows, I am on that beach in Tahiti. And as I walk down the beach, I see walking toward me another robot. And I wonder, is this worthwhile? So let me end with one of my favorite views of the future, and an inspired cartoon. It says, if you can't read it, and in the immortal words of Al Jolson, you ain't seen nothing yet. Thank you.
Be kidding. There is no way to follow Bob Lucky. Ed David. Well, my first task is to comment on some of the things that Bob said. I'll start off straight, if that's possible. The issue of fiber optics is a very serious one and a very wonderful one. Bob lauded its properties. I'd like to say a few words about that. I'm sure most of you are aware that a fiber optics channel will carry light much more effectively than a copper wire will carry electricity. Just look at the distance between the repeaters. It's made out of glass so clear that if the oceans were made of it, you could see the bottom of the Mariana Trench from the surface, the deepest trench in the ocean basin. One of the problems Bob mentioned was using fiber to switch light. It's not yet here. A more immediate problem is tapping light out of a fiber optic channel without much loss. That's needed right now in our local area networks. We don't have that. And those two developments are right now impeding the implementation and the installation of fiber optics. It's coming. It'll be here before the end of the decade, probably. Capacity glut that Bob talked about. He mentioned we're going to have packet-switched data. We have it. Packet-switched voice. It's about here. I wonder when we'll have packet-switched video. We predicted packet voice and packet data. Nobody has yet predicted or calculated when packet-switched voice will be more economical than circuit-switched. Video will be more economical than circuit-switched video. And the funny thing about video is it's the one resource, it's the one media, as Bob mentioned, that can possibly begin to use the glut of capacity that we have. Now, what is most of video? It's entertainment, as Bob said. And when is entertainment? At night. That's when the burden will be on our communications plant, which means the nighttime rates are going to be high and the daytime rates are going to be low, and business will love it. Bob mentioned that we need access to the home. Right now we have 1200 bits per second, perhaps at high cost, and we're looking forward to 64 kilobits per second. In fact, developments are moving very quickly. Today, you can manufacture for $5 a 2000 bit per second modem, which you can install in your personal computer right now. That is available. And moving that to 64 kilobits is something that this decade will surely produce, and much more than 64 kilobits, once those fiber optic channels that AT&T is talking about installing reach the home. Bypass. Sad fact of life is that 1% of the business customers generate 40% of the business revenue for the Bell operating companies. If that 1% bypass, the revenues drop by 40%. That is a frightening fact of life. And yet we constantly see in our trade magazines that bypass is the thing to do. And they'll give you a list of ways to do it. They hold conferences about it. They write articles about it. And if you can't read, they'll give you a little do-it-yourself chart to figure out how to do the bypass. Bob said quite a few words about fiber optics and some words about semiconductors, and he talked about communications. We're aware that on a chip, the majority of the design effort, the majority of the silicon, the real estate, and the majority of the power loss is devoted to communications. And yet some of the principles, the modern principles of packet switching, broadcast communications, shared dynamically allocated capacity are not yet applied at the chip level or within the computer industry at the CPU design level. Have you ever looked at the back of a CPU? It looks like that first Western Union picture Bob put up there. It looks like a rat's nest. No clever communications yet being used by the computer industry itself. Bob also said a few words about memory. Just like to add one interesting fact about that. Predictions are that by the year 2020, one video disc will be able to contain everything that's ever been written since man has come onto Earth. One video disc. Now we can take that and put it into Bob's robot, and then you wonder if the robot's going to want to talk to you. It'll have it all. Well, let me say a few words about what's good and what's bad. Let me begin by talking about some of the, well, one big success we've had in the last decade, and that is simply that we can move data from one place to another quickly, reliably, and cheaply. 1970s produced that. A major failure. We have no idea how to either design, evaluate, or conceptualize about distributed systems in general. And that's really what Bob was talking about, a distributed world of communications and processing. We don't know how to deal with that. People are putting them together all over the place. Personal computer networks are arising. Nobody understands what the trade-offs are and what the appropriate design philosophy should be. And so we find ourselves in the following kind of an environment. In our laboratories, business places, homes, we're seeing large collections of devices, terminals, that want to attach to processing devices, to goodies, storage devices, processing capacities, and people at the moment are connecting them up in a traditional way, which turns out to be absolutely wrong. Because everything we've learned about communications in the last decade says that you do not want to isolate and allocate a single communications resource to a single user. It's absolutely cost ineffective. Rather, what you want to do is to basically bathe everybody in a common communication medium and have them share it dynamically, as Bob suggested. So the things which have come about in the 70s, first of all, was to provide value-added networks to connect all these things together, and then to devise local area networks to connect you at the local level. And I'm showing you here the three well-known solutions, common solutions to the local area network game: the bus, the star, and the ring. Now, the other thing that's developed, and developing in the 80s and 70s, is that there's lots of these networks around, all over the world. And the problem of having them talk to each other, they're incompatible. They don't use the same block size for bits. They don't understand each other's protocols. One must introduce these protocol converters, these gateways, which allow dissimilar objects to talk to each other. Very difficult problem, usually very bad solutions to that problem. And of course, each one of them has their own local network for gaining access. Then you will come along with your terminal and you wonder where to stick it. Well, that's a problem we're facing right now. Of course, this is not the final picture you want. This is far too complex, as Bob pointed out. No way does the user want to see any of that. He wants somebody to surround it with, you can see that about as well as I can, to surround that with a service which provides the processing component, the electronic mail, storage, huge databases, education, printing devices, and of course entertainment. Now, as soon as you create a situation like that, and that'll come in the next decade perhaps, if we're lucky, as soon as you do that, you automatically introduce a series of problems. First problem is one of standards. Now, you and I know that the UK and France will never agree on a standard. Okay? It must be imposed from above, and that's what the Swiss are doing in Geneva with the CCITT. That's only one kind of problem. There's the issue of protection. Are these networks private and secure? Absolutely not. Many of them are broadcast networks. Anybody can listen in if they choose to. Then there's the question of nationalism. Is it true, for example, that when anything crosses your sovereign national borders as an export, it must be subject to duty and customs? Or if it comes in as an import, the same thing? And is it true that data is an export and an import? Well, if it is, as the French absolutely say it is, then it must be interrogated, understood, and customed and protected. There goes privacy, for example. Major legal issues about trans-border data flow. Another problem we have to face. Other issues in nationalism and legal issues. Certain countries have certain customs you must obey. As you know, in Japan, you can't even talk about installing a telecommunications network until you go through a tea ceremony. In Beirut, you cannot install a telecommunications line. The terrorists will blow it up. Third world countries, they don't want to lay copper wire, they want to feed their people. So how are we going to get this international integrated services digital network in the face of those kinds of problems? Sociological problems. We now have a new term in our technical vocabulary. It's called technostress. We're told that technostress is absolutely a home wrecker, destroying the family, marriage. People are spending too much time at home. We're told, for example, that in the office place, it is not the liberation of the office worker, but they're being chained to their terminals. Eye fatigue, possible radiation hazards. There's going to be a reshuffling that takes place until the skills of the individuals match the technology and the conceptualization matches it. Business, employees, and skill training is going through an enormous reshuffling to match this revolution that we're facing right now. And by the way, there's another sociological issue we can refer to. This reminds me of a story told to me by Professor John McCarthy, who's currently at Stanford. He was going to write a novel one time, and the plot was to be the following. There's this great professor, and he builds this enormous computer, and he begins to converse with it over the teletypewriter. And one day, the machine indicates it would like a voice. So he goes to Bob and asks for one of those telephones. He gets a telephone and begins to and a speaker, and begins to talk to the professor, and eventually makes outside calls and talks to the rest of the world. And very soon it begins to engage in business and international intrigue and multinational corporations, and really has a wonderful time dominating the world. And meanwhile, the little professor's in his basement with this machine back there, walking back and forth, and the machine looks down and says, "You hate me, don't you?" The professor says, "Yes, I hate you. You don't discuss with me anymore." The machine says, "Well, you know, you can always pull my plug," which is the solution to most of our problems with robots. The professor says, "Yes, I can," and he actually pulls the plug. And the machine winds down, and the room is quiet. And the professor begins to wonder. He says, "You know, the machine knew I could pull its plug. Why did it coax me into doing it?" So he plugs it back in. The machine winds up, comes alive, and says, "I knew you'd do that." Okay? You can't pull the plug. Not when you commit your national economy to an automaton such as that. Well, given all of those things, and you can add to this list better than I, you come to the bottom of the list, and you finally find, yes, there are some technical problems left, but they're easy. They're handled by people like you from the IEEE, scientists and engineers, people who understand how to solve a technical problem. Unfortunately, this is not the stumbling block, and Bob referred to that problem. It is these softer issues which will determine how quickly we reach the kind of system and eventual ideal that Bob and I have been talking about. Thank you very much.
Thank you, gentlemen. This was most stimulating. Have any questions been stimulated? The questioners will please identify themselves. Who has the first question? Dr. Schwann?
You were talking about circuits, distribution systems, and how to handle that, and how difficult it is. And that was very amazing to me, since it reminds me about something else. Namely, our own distribution system. We haven't still been able to figure out how it works. We have many generators, many amplifiers, and they are all intertwined, but we really don't know how it works. Do you see any parallels here?
The question has to do with the parallel between the distribution systems that were being discussed and the distribution system up here. Are there any parallels?
Well, in response to that, there's very little known about what goes on up here. We don't even understand how we implement memory, much less computation and logic. I dare say that the research in that direction will take many more years before we make any progress. But once we do, it'll far outstrip any of the artificial intelligence we've seen in the computer industry. Artificial intelligence is able to make a big splash very quickly, but significant progress will come only when the physiological understanding comes about. Now, I'm also intrigued by the parallel. I have no idea how to approach it. It's a leaky system with heavily coupled transmission. Everything the telephone company does is to isolate transmission, put insulators and shielded cables around it. Communication system up here seems to depend upon all kinds of leakiness. Okay, you can cut half of it away and it still functions sometimes. Well, you can't cut half that telephone system away. You can't cut half the power system and expect no brownouts in the world. So it's a very difficult system. I believe our approach in computer science is not at all parallel to the way in which physiological systems work. In one ant, you've got more capability than the world's computing power right now.
Do you have any comments on that, Dr. Lucky?
Well, maybe your mind works differently than mine. I'm just kidding. I agree with what Dr. Kleinrock said. The only point of disagreement is you can cut half the telephone company away, and you'd have half a telephone company.
That's what happened.
And also, in the talks tomorrow, possibly by Carver Mead or someone else, this issue may come up again. And if you're interested in it, I think tomorrow, stay tuned in.
Another question? Yes, sir.
We're having a lot read anything or write anything. How can we keep that trend from?
Well, just a second. Could you hear that? No. The question has to do with the fact that with all this entertainment coming into the home, our youngsters are not becoming literate. How are we going to cope with that problem?
I think what you say is, I think it's true. I don't know if the data really backs that up, but my children don't read that much. But I do think that there's a lot to be said for sugarcoating education and bringing it into the homes of the future. I think there's every potential there for bringing education into the homes, but whether the people in education can package it in a palatable form remains to be seen. And also, my parents worried about how I was getting ruined, and I worry about how my kids get ruined, and I'm sure my kids are going to worry about how their kids get ruined. And kids are pretty indestructible. You know, it's amazing.
In the back.
Robert Convalescent, I just make a remark on the last question. It's been found that when the personal computer has been generally used by students, it is intelligence. It's used very effectively in the humanities. And the humanities people report that the writing has improved greatly since they've been using word processing to hand in assignments.
Could you hear that?
The composition capability has improved greatly since they've been using word processing to generate their assignments.
Any comments on the comment?
What I'd like to embellish on this issue, slightly different tack though, one of the things we're very proud of in this country is the fact that our youngsters are so good at the game of computing and information processing and writing programs and being innovative in new structures. And it was mentioned earlier this morning that we face a threat in terms of the number of imports we're receiving, challenging certainly the camera market and the home entertainment market and a variety of other devices. And we pride ourselves on the fact that the Japanese, so far, are not as creative as our youngsters in the same game. Well, the reason our guys are so good and our gals are so good is because they've grown up with good computing facilities, good hardware, good software. That is now changing. Countries around the world, Japan in particular, are providing excellent computing facilities for the youngsters, and they're going to become every bit as good as us very soon. So in terms of making our youngsters capable, we've got to somehow find a leap forward again.
One more question. Who has it? Mr. Hargens.
I believe everything we've done and said started out with that. I think the lady beside me would like to know, with all the added capacity, et cetera, how many more pages will there be on the bill?
It's going to take a number of pages just to have all the decimal points.
The question has to do with the fact that with all of this added capacity, how many more pages will there be in the bills we receive?
That's right.
Say it again.
Oh, I just said it's going to take all those pages to have all the decimal points, associated with what you're going to have to pay for all that.
Very well. I will excuse you two gentlemen now, and will ask the last two panelists to come forward. The final two speakers this afternoon